Hello everyone. We will start our playlist on the linked list. In this playlist, we will discuss completely about the linked list. In this playlist, we will cover near about 60 videos on the near about 30 plus most asked DSA problems. These problems may be taken from the Stiver playlist and lots of the playlist, but mostly we focus on the linked list, the data structure. We cover the complete of that. Let's start one by one. What was the linked list? What was about that? Let's first was linked list. In the linked list, the data was stored not like the arrays, stacks, queue. There have some space. Here we also create a node for that as the linked list and store the data inside it. For example, take in like we have an array. There was already have elements to store like 1 2 3. We no need to create that structure for, but for linked list we also create for the that structure also. So for that we use the constructors. And the major thing about that, the linked list data was also the dynamic memory allocation. In the linked list we also store the data at the dynamic time. Then what was the dynamic time allocation means, linked list does not have static size. Like for example, like for array we have like array of 5 elements. We have to declare first, we store only 5 elements, but in the linked list we don't need to declare anything, so the memory allocate at the runtime. And the linked list have the two major things. One was the data and the another was the link for the next. These two things are most important, data and the next. Data was inside the node, the element, the number was that. For example, the data in the data is not like the number that we storing. Like we have a node and here was the one, here one was the data, and we contain the access of the next pointer also, like that. And the every node have two things. Like for example, imagine this is a node that we contain here, that contain two things. One was the data and the another was the pointer of the next reference of the next pointer. This was the another thing like that. But if we want to traverse on the another thing, we have to access of the next element. Then but why we have the access of the next element, why we need that? For example, the storing of the linked list was not like the another data structures. Like when we create a node, like we create a node for the element 2, and it was not shared at store at the any point. Like in the memory there was a, like imagine this to the memory, it was the not store like here, it can be stored anywhere. And the node the next was stored in here, it can be stored anywhere. So we have to access the next pointer. Like one more node here stored and the next was stored here. So then how was the memory think and access them? He can find the here, but he not find go for at most how much far about that. So he contain the access point of that. Like he have his address. Like when we need the another node, he want to access that node, he immediately know his address and go for there. And here was he was. So the data was not stored in the other like that. And the other thing, like how do we create that, how do we create that structure and store the data inside it? We make a first name it what want we create. We create a list node created. After that this make this class, and next two thing what we have to store. One was the int value, as I tell you, this value data that I says you. And the next was the next pointer, this reference of the next point. Then you asking first was the int, next was the list node. Why? Because we have the next addresses. This was the, you understand that why we make list node, because this was a list node. And int was not mandatory, it was int. Like here we storing 1 2 3. Another it can be string, anything, any object, anything it can be. Then list node data that was changed for the every node, and the node shape was the same for every node. Then we make it and we have to create multiple nodes, so also take the val means node. Okay, in the next video we will discuss on the implement this in the code. Okay, and after that we will see the insertion at beginning and middle. For deletion also see beginning, middle and the end, all three for insertion and deletion.